Okay. So hello everyone and welcome to our last lecture. Today for data analytics and business intelligence course, we will be diving into a very practical and widely used marketing framework. We can see it's a marketing application called recency, frequency, monetary, which is abbreviated as RFM. Okay, RFM analysis. Okay, this is recency, frequency, and monetary. So what is RFM? So it's like a framework, a building block that use customer metrics, three of them. First is the R. R stands for recency, which what it mean by recency? It means how recently a customer made to our shop to purchase our goods in the shop. For example, you just go to 7-Eleven today. That means your recency is 0 day. Okay. Next is F. F is frequency. So frequency looks how often a customer makes any purchase at our store. Okay, so maybe you go to 7-Eleven like every day. So your frequency is maybe for the whole year is 365, for example, right? The higher, the better, right? Recency, the smaller, the better, because the most recent you get the smallest days. Okay. Finally, the M stands for monetary. Monetary is money, right? So it evaluates how much the customer spends at the shop. So together, these three dimensions give us a view, a comprehensive view of how customer engage with our shop or our stores, right? So, why do we use IFM model? The primary purpose is to segment customer based on these three behavior. So in traditional application, marketing department, right, use this to make and prioritize the marketing efforts and resources. Usually they will use maybe demographic data like age, like gender. So female like this, male like this, for example, age, Gen X like this, Gen Y like this, for example, right? But these demographic data only tell you who your customers are, not exactly what actually they do. But IFM is like a behavioral ก็คือพฤติกรรมเนาะ segmentation which gives us more accurate predictor of uh, current actions and future actions. So if we understand this behavioral segments, uh, the shops or the organization can strategically prioritize their efforts to allocate the resource more effectively. For example, you don't want to spend time or spend budget or spend marketing strategy on people who never come back to your store at all or really hate your 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 goods or uh, your things that you sell in your stores, right? So you can think of this IFM model like an extension of another framework called Pareto marketing. What's Pareto marketing? Pareto marketing is a principle that tells you that, okay, uh, you do only 20% of the targeted work, but you get 80% of your total efficiency. So do 80-20 rule means do only 20, you get 80 efforts. Okay, like this. So better off than doing 80 but just get 80, right? You do only 20 but you get 80. So this is quite a better things to do. So in a practical business setting, this means that IFM model will help marketers to focus on the premium group or the top 20% of the customer group that should be your first priority, right? So how to find this 20% of the customer group, like a VIP group or almost VIP and VVIP, right? So you maximize your return on the investment that you have the budget, right? Without overextending your budget to people who will never come to purchase anymore. Okay, so finally, we will try to move on to the technical application by direct your attention to uh, this link. If you follow this link, this is a very good Thai article that tells you about what is IFM to solidify you to understand the theories behind what we are discussing today. So if we go to this link, okay, you'll find this. Put this in the chat. Okay. Okay. So if you go to this link, it will tells you what is IFM, how to uh, calculate RFM, and then segment customer of the IFM model into several segments, customer groups. And for each group, okay, they have the nicknames of each group, and then also the suggestion of what we can do with that group of customer. So I will give you probably 5 minutes to skim through this, and then it will help you to understand this better. Okay, so it's 1:43, right? So it should be 1:48, and then we'll come back and talk more about this. All right. Okay. So I think you have understand a bit more about RFM. We will talk about practically how we do this or calculate this. Okay. So from that uh, uh, website, I capture this segments map to talk a little bit about this. So let's first understand the axis. So on the horizontal or x-axis, we have the recency. So as you move from left to right, if you move from left to right, it means that the customer has purchased more recently, right? More recent, more to the right, okay? On the vertical axis, the y-axis, there are two metrics that were combined together, which is frequency and monetary. So we uh, multiply frequency and monetary together and then divide by 2, which means we try to average out what it mean by frequency and monetary. It means that they are very loyal loyal L O Y A L loyal คือเหมือนพักดีใช่ไหมพักดี they are very loyal, they often buy with us, and also they use more to spend with us. Okay, so as you move higher up to the y-axis, it means you are looking at the customer who buy often and spend a lot. Okay, so by plotting, we don't have the third dimension, right? We combine two dimension 2 and 3 together so that we only have 2D maps. Okay, so by plotting these two dimensions against each other, we can distinguish behavior naturally from most of our customers. So let's look at the four corners first. The top right is champions, right? We call champions because they are high recency, high frequency, and of course, high monetary. So these are your absolutely best customers that you ever have. So they bought recently, they buy very often, and they also spend heavily. So strategically, you don't need to offer them any discount because they will always buy with you. They love your store. They love your brand. So instead of give them the discount, probably small discount would be fine, but you give them some VIP, for example, rewards or access, the early access to the new products, for example, right? Now to the bottom right, you have new customers. That means they are just recently buy with you, right? But they may just try to buy. So the frequency and monetary is quite low. And they just probably just discover you and make the first purchase. So your goal to the marketing department here is that try to squeeze, don't no, not try to squeeze them right now because they may not be sure yet with your products, but you try to provide them with some excellent customer experience or post purchase or maintenance experience to keep them to come back to be potential loyalists later on or promising loyalists later on. Okay. On the top left, we have can't lose them or at risk. Maybe we talk about these two together. Can lose them and at risk. This is quite a critical danger zone because these customers have very high frequency and monetary scores, meaning that they used to be your best customer. They used to be on this side, but they moved to this side because of something, right? Recency is extremely low. They haven't been back in a long time. Maybe they had a bad customer service, or they may find some competitor, right? This segment require aggressive uh, win back campaigns, right? So you need them. They used to spend a lot, but why don't they spend recently? There must be some explanation or some question on this that you need to solve. Okay. On the bottom left, loss. This yellow one, right? Lost, hibernating, and even about to sleep. These guys, they bought once, maybe a long time ago, and didn't spend much. And so in the view of return on investment, they are not the segment where you should spend but budgeting on, right? You don't need to consider them much, just let away. Okay, so we have the middle, right? Like need attention, about to sleep, potential loyalists or loyal customer, these guys. Okay, so we need to try to find how or the way to use data to drive what they might be good at or what might be good strategy for each of them. So by using this segment maps, we don't need to look at spreadsheets of thousand or 100,000 of customers anymore. You just try to segment them into a clear group, and then we try to target each group differently. This is what we need to do. Okay. So how do we get this segment of customers using Tableau? Right? We will do this right now to perform the RFM analysis. Right? We use again Superstore dataset to build this from Tableau step by step. Okay? But before we doing that, we have 5 fundamental steps to complete the RFM analysis. First thing is to, of course, gather the data. This data has to be transaction data with fields like customer ID to be able to distinguish each customer, right? You need to have date, otherwise you cannot calculate recency. You need to have the amount, right? You need to amount because you need to know the monetary, the money that they spent. Okay, so these are 3 things that might be mandatory to be able to have in your data to calculate this RFM. Once you get that data, you calculate the scores. Individually, calculate R, calculate F, and calculate M. Then, once you get individual score or individual raw metrics, you try to assign a standardized score in the 3rd step. Right? Standardized score probably usually will be from 1 to 5, right? For each metric, from 1 to 5, F from 1 to 5, and M from 1 to 5. Usually what you can do with this is that you will normalize it using some thresholds, or you can normalize it. In this case, we will normalize it using percentiles, okay? And then once you get the normalized score of each individual metrics, we will combine those scores together into an RFM score, such as 555. It means R is 5, F is 5, and then M is 5. So this is our best customer or champions, right? Or you have 111. This is the least active one, right? R is 1, F is 1, and M is 1. Once you get the combined RFM score, then you group these into customers, into segments, and then from that segment, we can now have actionable strategy for each of the segment. Okay, so let's do this step by step. Okay, so the data that we use is sample superstore. So just open your Tableau right away. Okay, and then use the data source sample superstore here. Okay. All right. So this is the default one that we use, right? So when you go to data source, right, we have orders, we have people, we have returns, right? You can use either 2025 version, which means it has 4 years from 22 to 25, or if you already upgrade to 2026, that's fine also, right? It will have 23 to 26, that's fine. Don't worry about the date, okay? Okay, make sure you load the sample superstore. And in sample superstore, you can see that this transaction contains order ID, right? Contains customer name, which can be our customer ID, right? Contain order date, right? So we will use order date for recency. We will use order ID for frequency. And we also use sales for monetary. And of course, we have customer name. So we will distinguish by customer name, not customer ID. Okay? So once you get this, just type 1 for me. Thank you. Okay, now we will create the metrics, the law metrics. First, recency. What is recency? Recency need to calculate the number of days that each customer's last purchase, right? So we will use one thing that we haven't talked before with trouble, which is called level of detail. Okay, so how can we use level of detail? We talk about level of detail expression first, LOD, level of detail, right? It means that it allows you to compute values at the data source level as well as the visualization level. So they give you some control over the computation of data at different levels of granularity within Tableau. And there are three main types of the fixed level of detail expression, which is fixed LOD, include LOD and exclude LOD ก็คือ LOD เนี่ยมันจะทำให้เราสามารถ control การกรุ๊ปนะอย่าลืมว่าเวลาเราเอ่อเอ่อดึงอะไรเช่นสมมุติว่าเราดึง for example if I do this for you right if we for example we drag region too low, right? Everything that will be calculated on this will be grouped by region, right? But sometimes although the view says, okay, this should be grouped by region, but we want to compute something that is not grouped by this region, but grouped by, for example, customer name in our case, right? For example, if you put, let's say sales, right? These cells will be grouped by region only. But if you want these cells to be grouped by customer name, don't need to group by region. Group by region later on, but group by customer name is the main thing. Then you need to use level of detail. Otherwise, you cannot control how you group by it. It is controlled by what is shown in the view, right? So that is the things that we reduce, which is the first one, fixed LOD. So fixed LOD means you compute the value using only the dimension that you explicitly specify in the fix. Okay? So what you do is that you use the keyword fix. You use the parentheses like this, right? And then you use the keyword fix, and then followed by the name of the dimension. That means you want to group by this dimension whatever your view has. For example, your view has region, right? But you want to group by customer name, you just put customer name here, and then colon, and then probably by your calculation, whatever measure you want to calculate. Okay, so this calculation will remain fixed, as its name suggests, will remain constant across your data set, no matter what you group by in your view. So the thing is that it will be independent of the granularity of the view. right? So the use case of this is like you want to benchmark to compare across some fixed category. You won't want to change it by the wheel, right? Or you need to calculate some ratio that has the numerator or the denominator to be fixed according to some dimension or some global things, right? So let's get back to our recency. So in this case, we want first to compute for each customer, right? For each customer, that means no matter in the view we calculate or group by whatever things, we want to group by customer name to calculate this. So we will use fixed customer name. That means it will calculate by customer name. What do you want to do? You want to calculate recency, right? You want to get the max order date นะคะก็คือแต่ละ customer เนี่ยต้องหาว่าล่าสุดใช่ไหมนาย A เนี่ยไปซื้อเมื่อไหร่นาย B ไปซื้อเมื่อไหร่ไม่สนใจหรอกว่าในวิวเนี่ยมันจะมีค่าอะไรอยู่นะคะหรืออาจจะมีฟิลเตอร์อะไรอยู่ในนั้นไม่สนใจฉันสนใจแค่ว่าเนี่ย customer คนนี้ customer A เนี่ยล่าสุดเขาไปซื้อเมื่อไหร่นะคะ you will get that number that data from fixed customer name. So for each customer A, you get max order date. B, you get max order date, right? And also, if you don't specify dimension like this, just fix, right? You will get the global, right? So in this case, if I do fix max order date, that means it is the global max order date. Actually, you have seen this before when we did the statistical analysis, but I didn't try to explain you at that time, right? Because we know that we will encounter this fixed LOD again here. So in this case, what we need to calculate is that we need to find number of days between the last days that the customer come to our shop, right? And the date of the max order date of the whole transaction. Actually, this should be today. But since you know that the sample superstore may not be the update that data one, or it may be it's not the real data, right? So instead of having date dip, we want date dip day, right? Between customer or max order date and today. This is the real things that we want to do, but we cannot do here for the sample superstore data set. So in this case, we want to find the date dip number of days between that customer order date and the global max order date. So it should be like the last day of the last year in the data set. For example, 31st December of 2025, for example, right? So this will give you the number of days, and that number of days is the recency score. For example, let's see, I have the example here, right? For example, if I have the data set looks like this, I have customer ABC, right? And these are the order date of each customer. So customer A comes to 2 times, customer B comes to twice again, customer C only come once, right? So the first term fixed customer max order date, you give you this date, this date. Customer A is this one and this one, right? So the max order date of customer A is 10th February 2024. The max order date of customer B is 20 February 2024, right? And the max of customer C is only this one, right? And the second term fixed max order date will give you the last overall order date. For example, the last overall order date in this case is 20 February 2024. So when you try to compute the date diff, the day between these two, right? You will get 10 days for customer A, 0 days for customer B, and 5 days for customer C. Okay. So this is what we want to get from this recency. So let's go to our Tableau workbook, and then we'll create a lot of calculated field. Okay, so we go to create calculated field. right? And then this we will call it what is called uh, maybe raw what is called what I call in the slide IFMR. Okay, IFMR. Okay, so in RFMR I want to calculate the diff get the number of days, right? And then use the LOD fix customer name, right? Customer name, and then calculate max order date. Okay. And then from actually the real thing is today, but this is the real thing that we want to do, right? But we don't do this. Instead, we do the global max order date, which is fix and without dimension name and max order date like this, right? Okay, it should be like this. Okay, and click OK. Click OK.
อาจารย์
this
ครับพิมพ์ตามไม่ทันครับอ๋อขอบ
ค
คุณ
รู
ครับ
พิมพ์ในแชทละค่ะ ดูในสไลด์ก็ได้นะ ดูในสไลด์อ่ะ Okay, and then let me title this RFM calculations. Okay, RFM calculation, and then let's have a check of the value whether we calculate it correctly or not. So for each customer name, right? For each customer name, we put customer name into row. Right? We have like about thousands of customer. Okay, from ABC to Z, right? And then we have the what do we have? Okay, recency, right? Recency. We will check this. Let's see the max order date of each customer. So I will get another calculated field. Okay, max order date. Okay, let's see. Fix. So this is like a double check thing. Fix customer name, max order date. Okay. I want to see the last day that customer comes to the shop, come to the stores. Okay. Fix customer name, max order date. Okay, and then I put that max order date. Right. So it's year, right? I want to display it as custom and then Monday year. Okay. You can see Aaron Bergman last day come to Sample Superstore is 10th November 2024. Note that for this data superstore is the 2025 version, so the last day should be 31st December something of 2025. If you use 2026 version, it should be 1 year later on. Okay. And then let's put the IFMR, right? We put IFMR to the rows. Okay, it becomes bar chart, right? Because IFMR is like number of days. Okay, but we can force this to be to be a text without the bar chart. So how can we do that? We change this to first attribute and then change also to discrete, right? So you get this IFMR numbers. Change the type of the field so that it will display just like a dimension, so that it will not calculate any or change it to bar chart for you. So get to attribute and then discrete. Okay, discrete and attribute. Attribute means that it will show the real data. Since IFMR already calculate for each customer name, you get one data, so it will show you just one number. Okay, change to attribute and discrete. Right, we get the blue pill here. Okay, so you can see that Aaron Bergman last day is more than 1 year, right? So his recency is 415 days. Aaron Hawkins is a very good customer. They just come 12 days ago, right? 18 December, because the last day is 31st or 30th. Right? And so these are all the data from our thousand of customer here. So if you get this, just type 2 for me. Thank you. I think we already get the recency. Okay, let's get back to slide first. We talk about the first type of LOD, which is the type that we use mostly in our example today. Okay, we will not use the other tools, but we will talk about it a little bit. Right? For include LOD, this include LOD means that we want to as contrast to the fixed one, we want to, in addition to the dimension that already in the view, we want to also factor in the dimension that we says in include, right? So include mean please also group by these, things like that. For example, if I have region group by in a view and I said include customer name, I means that in addition to group by region, I want to also group by customer name also. So this is the include one. So the use case of include one is to factor in the dimension that dynamically along the any views dimension that we already have, right? So we want to use this when we want to just keep update. When you add some filters in or when you remove some filters in, you want to also factor in this dimension also or group by this dimension. For example, you want to uh, calculate average customer spend per region, right? You have a bar chart showing 4 regions, like what we have, right? West, something like this, east, right? North, south, for example, right? And then we want to have uh, show the average a single customer spends in each of these region, right? So if we just drag average sale, if we just drag average sales, we will just get the average sale for the whole thing, right? For the whole region, how many transactions in the whole region, we get the average. It's not the average of each customer. So if you want to get the average of each customer, you use this. You use average to include, right, customer name. So that when you average for each customer name, you sum. You sum first. So for each customer name, you get the sums, right? And after that, you use the average. You will get the whole average of each customer because one customer may come many times, right? You only want to get for each customer how much they averagely spend on your on your stores, right? So this is the way that you can do using the include LOD, right? So this is a classic example that you may want to use include LOD. For exclude, okay, exclude is to remove, right? Include means to include. So exclude means to remove the dimension from the dimension in the view. This is highly useful when you need to calculate some value without the influence of particular dimensions, but still consider other dimensions that are in the view, right? So it's like an opposite of the include one. You want to eliminate that dimension in the view, right? For example, you can do percent of total. Actually, you can do percent of total with the table calculation, but sometimes you want to do it yourself, right? You can use the exclude one, which when you have a bar chart showing sales broken down by region, then by category, and then you want to have a stack bar chart, right? By region, north, south, something like this, right? And then you want to get the stack bar chart of furniture, yeah, office supply, something like this. And you don't want to, actually you can use the table calculation very easily, right? But you can also use exclude, right? To just to show the percentage of the region of total sale comes from each category of this, right? So if you divide some sales by, if you sum sales by some sales and you want this, you will not get that, you get 100% for sure, right? But what the solution is that the denominator, which is this one, has to exclude the category, right? Some sales, right? Something like this, you will get the fraction of the tableau that looks at specific category sale, right? So this is what you may use exclude for. So maybe less powerful than include and fix. Okay. So now, in this case, we use mostly fix. Okay. So we got M, we got R, right? Now we will do F. F measure total number of the transaction for each customer. That means how many times, right, that customer comes to the stores, right? So what you calculate is fix, again, customer name, and count the order ID, but count this thing, no? Remember that for each time, order ID may comes in several rows, right? 1, 1, 2, 3, 2, 6 has 3 rows. We only count once for each order IDs. Therefore, we need to use the count this thing here. Okay. So RFM create another calculated field and then RFM F Okay, so IMF is fixed customer name again. Count this thing, right? Count this thing order ID. Okay. Make sure the calculation is valid here. That means you have the open parenthesis and then close parenthesis correctly. And click OK, right? And then we put IFMF right beside this. And then again, we change to attribute. We change to discrete. Okay, so RFMF for Aaron Bergman is just 3. So Aaron Bergman's come 3 times totally. Aaron is a better customer, came 7 times, right? Who's the best? Looks like, right? Whoa, Emily Pan came 17 times, right? Yeah, this is the number of times, the number of orders, order IDs. Right? Okay, if you get this, just type 3 for me. Thank you. Okay. So this is a lifetime number of purchases, right? Since we have only four years, right? This is lifetime. In this case means the 4 years that we have the transaction data. Right? The last one is the monetary. Okay, so the same thing. For each customer, we fix the customer name as our dimension, and then how much they contribute to the shops is some sales. Right? So calculate that field, and then RFMM. Right? Fix customer name, some sales. Okay. Okay, then click OK, and then again put this up, change to attribute, and then discrete, right? So looks like Mr. Aaron Bergman came just 3 times and that didn't spend much, just 800 something, right? Mr. Aaron Hawkins spent more, 1,000, because he came more often than Aaron Bergman. Looks like Adrian is a good customer, right? Adrian Barton spent 14K plus, right? So these are raw calculations, but we will not use because you can see that this raw calculation has a vast variety of the numbers, right? Now, what do? We will normalize, right? We'll normalize these RFM by creating just the scores that has limit. For each metric, will be used 1 to 5 score. Right? Again, we'll use calculated field to assign this score based on maybe percentage, right? Because if we use the raw data, you cannot like effectively compare uh, the total dollar spent, whether 20 days and 21 days, which is it the same or is it different, right? Something like this. We want to assign another metrics that should be the scale, less number of scale, right? In this case, only 5, 1, 2, 3, 4, 5. But question is how can we draw the lines between maybe 1 to 2, 2 to 3, 3 to 4, 4 to 5, right? There's no exactly the right single answer. It depends on the context, right? How do you choose the method? Depends on the business context. The first way and the way that we will use today is to use just percentile. Right? So this is the most common approach that we usually see. Uh, let's say top 20% you get a 5 score, right? The next 20% you get 4 and so on, right? So the advantage of this percentile method is that it's quite objective and handles outliers smoothly because outliers still in the top or the bottom, right? And it usually will be evenly distributed because we use percentile คือมันก็จะแบ่งเท่าๆกันนะคะ The cons, the disadvantage of this percentile method is that it's quite relative and shift every time your data update, right? A score of 5 today may be like 500 for monetary value, but the next month this score of 5 may drop or may goes up, right? It depends on the seasonal sales, right? So this could shift, and then how do you interpret the 5 score change quite often, okay? Another way is to use absolute score, absolute threshold, right? Instead of let the data automatically do this cutoff, you can use the business definition to strictly or hard code rules to define how much should be 5. Maybe like if they recently come 7 days ago, it should be just 5. If they come between 8 to 14 days, it will be 4. Or if they come over 60 days, it's 1. Things like this, right? The advantage of this is that it aligns with the business context, right? So in business, maybe we have like uh, our shop is grocery, so people will come like weekly. But if our shop is the clothing store, they may come like season, right? Maybe quarterly, not weekly. So we can use the business context to get this threshold that are suitable for that particular products or particular shop. But the cons of this is that you need to know the domain knowledge to set this threshold correctly, right? Okay. Another way are more complex. This another way is what you may already learn in your machine learning class, right? Use algorithm to group, and the most notable algorithm that you may use is k-means clustering, for example, right? You use the machine learning to try to group between what should be 5, what should be 4, what should be 3, or what should be 1, right? So this is quite machine learning ways to do that. And the pros is that it tries to organize the group into some behavior that may suit particular data set at that time, right? but it's not fixed like percentile. The cons or the advantage is that you need to compute. And this computation may be heavier if your data is much larger, right? And how do you understand what is 4, what is 5 may be harder than having the cutoff threshold or the percentile range, right? So these are the ways that you do. We will do the most easiest one, which is using the percentile range. Okay, so recency, we will convert the recency score to standardized 1 to 5 using percentage. That means the most recent. The most recent means what? Smallest number, right? Smallest number, 7 days, 1 day, 2 days, right? This the smallest number in the top 20 percentile will be assigned 5. Okay, so we again use fixed LOD. If fixed, global fixed, see, we don't, we don't fix dimension. We don't fix dimension. We globally I calculate this. We use percentile to calculate IFMR, which already calculate per customer name already, right? So if we find percentile of the top 20%, this is the smallest number, right? 0.2 mean the smallest 20% number will be 5, right? Maybe just 1 day, 2 day, 4 days, right? So I will use if else. If IFMR less than or equal this percentile 20%, then we assign 5 score. If less than 40%, we assign 4 score, and so on until the last one is 1, score 1, right? Okay, so we do this and we call this score. Score score. Okay, if we use if RFMR less than or equal fix percentile of RFMR 0.2, right? And then close, and then right? Then 5, right? If RFMR, correct? Standard, then 5, okay. Okay, and then I will just copy this, and then I will use else if, right? IFMR less than or equal to 0.4, then 4. And copy again, 3 and 2, right? 3, 2. This is 0.6, 0.8, and then else, the last else 1. And then don't forget the end. All right. Okay, let's see whether we get it correctly. Okay, put this maybe, okay, at the end, and then change to attribute to discrete again. Okay, so this guy never come for a year or so, right? He gets one. Correct, right? This guy just come 12 days ago, right? He gets five. Yeah, very good, right? This guy 88 days hasn't come, so get about in the middle, right? Three. Okay. So looks like we calculated correctly, right? Between 1 to 5, right? Yeah. Those that have 100 days, right? You should usually get one or two. The higher the better, right? The higher the best, the better that customer just recently come. Okay, if you get this, just type 4 for me. Thank you. Okay, we do this for frequency and monetary, right? The same thing, right? You use, but the frequency and monetary are the opposite of recency. Recency is the least amount number, the better, right? But for frequency and monetary, the largest amount, the better, right? So how do we convert this? We change this, right? In this case, IFM less than equal 0.2 will be 1, right? So this is the opposite, right? And the same as monetary score. The lower the worst, right? The higher the better. So you get the highest one, 5. Okay, so let's do this together. Frequency score and monetary score. And once you get this, just type 5 for me. Okay. Just do whatever. Okay, calculate the field score for F. Okay. I will just change this. I'm lazy to do again. F. Okay. This become 1, 2, 3, 4, and then 5. And don't remember to change to F. F, 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 F. Okay. Or F. And the same as M. Just change IFMF to IFMM and then it should be done. Right? Okay, just copy this. And then I create another one. Score M. And then I change from F to M. Okay. And once you are done, you just check whether it's correct. F. And then M. Okay. Looks good, right? This guy, Aaron Bergman, is not a good customer. He gets 111. Frequency, not frequent, right? Monetary is very low. Right? This one is, which one is high? Yeah, 14K, very high, right? Get high monetary value and also just 10 days recently. Frequency, 10 times, you get already 5. Okay, looks like a good, yeah, 170, yeah, it looks like a good calculation here. Okay, once you're done, you get 5 from me. Thank you. Okay, just open this for you. Okay. Next. Okay, once we get this, right, separately, R, F, and M, we just combine this into one number. How can we do that, right? You combine R, F, M score. The easiest one is to concatenate the individual score into single three-digit or three-character code, right? Recency is 4, right? Frequency is 3, monetary is 5. We combine to 45. This is the way that should be called industry standard, right? So alternatively, you may be able to sum the individual scores into one numeric value. For example, 3, 4, 5, you add them up into 12, right? Of course, the second way is not quite standard because why? The most disadvantage things of summing all the scores into individual score is that you only get one number. And this one number will lose all generality, or loss all context, right? You don't know how much it comes from recency because many combinations can be 12, right? It can be 3 4 3 5 or 5 3 4, right? Or even 4 4 4, right? So if you just sum into just one score, probably problem is these three guys you may target differently, but you lost that uh, granularity when you combine to just individual store, right? This one may be like quite a loyal customer, right? Or another one's 255. This one buy very high, right? But they did come for a long time. So you need to do something to get them back, right? Not the same as this guy. This guy come very often, quite often, and spend quite a lot, and also just come recently, so we don't need to worry this guy, but we need to worry about this 255 guy. But when you combine to one number, it's 12, right? So usually people will not use this way, right? We will use this one way. So how do we do that? Very easy, right? The first number we multiply by 100, right? The second number we multiply by 10, right? You get scores into one number with 3 digits, right? So score RFM, right? First RFMR multiplied by 100 plus RFMF multiplied by 10, and then plus RFMM, right? This gives us like 555, right? 555. Okay, so let's check out who's gets who. Probably we can put it right here. Where is this numbers? Okay. Attribute discrete, right? Okay, so what's happened? What happened? What happened? Let's go. I used wrong one, right? I used wrong one. It's not, my bad. This is not IFM. This is the raw. I need to use the standardized one, which is score, right? Right. Score R. This is score F. This is score M. Sorry. I need to use the standardized one, not the raw matrix one. Okay. This look good. Aaron Bergman 111, right? Not a good customer. Aaron Hoggins 533. Aaron Smelling 334, right? Looks like good. Who's the best? Yeah, this guy. Harry Mary 555. Okay, once you get this, please type 6 for me. Thank you. Okay, so the question is there are many combinations, right? So how to map into segment map like this? This is the one possible way, okay, to map who should be the champions, right? You can label 555, 554, 544, 545. These seven guys should be called champions. Right? These guys should be called loyal. Right? You can see that to be champion, of course, you need to come uh, very recent, right? But you can spend not the best, just the two top best, 4 or 5, and you can spend quite frequent at the top 40%, right? 4 or 5, that should be okay. Or you can you maybe not be the recent customer, it can be full, right? But you either spend a lot or you either uh, come very often. These are all called champions, right? And loyal will be less VIP than champions. And you can see for those start with one, right? And some things 1 or 2, right? And monetary one, this should be lost customer, right? So this is the one way. I didn't mean that everyone should be like this, right? It depends on business context too, right? This is the just one example of combining things into segment labels, right? However, for our case, we would do simpler than this because you don't want to create a lot long if case, right? Or you don't want to take too much time on this. So I want to just combine into just 5 types. Okay? I call this 5 types. The first type is champions. The second type is loyal customer. The third type is potential loyalist. The fourth type is called at-risk customer. And the fifth one is called lost. So anyone with 5 as recency, I will give them champions, right? 5, either 555, 554, or 545. Either recency and monetary 5 is okay. Should be champions, right? And if the second one is 5, right? This I use string to convert the number of the score to string first, and then I use Smith to get the second number, right? 2 mean position, right? 1 mean just number. If the second position is 5, then I'll call them loyal because the second one is frequency, right? If he's not champions but he's frequent, then I would just call him loyal. I don't care whether just recently come or how much they spend with us. If the frequency one is 4 or 3, right? I will call them potential loyalist. Right? Not much like loyal, but almost loyal. If more than 133 means it should be or 2 something, 245, 2, not 245, 245 will become this 223, 234, or something like this, right? There will be at-risk customer, and less than this, it all will be lost. So just instead of 15 groups, too much, right? We don't spend time. We will use only 5 groups like this, okay? So right now it's 2:54. We will take a quick short break while we do this else if case for probably 10 or 12 minutes, right? So let's get back at 3 3 what 306 307, right? And then we'll see what happened with our 5 segments here. Okay. Okay, let me do this. Uh, the best way is I will just copy. Yeah. New calculated field. Customer segments group. Okay. So I need to, because score RFM is a numeric value, I need to convert using str to string. Because if I want to use the mid function, this is a string function, so that's why. And since we need the numbers to compare using numbers, I convert back to int. Actually, I can also don't need to convert back, right? I can like use the string equally comparison, right? Okay, and then let's check out. I just put this in the ABC. You can see there is ABC that I can put the text here. Just put this. Okay, it becomes columns, right? I put back to text actually. What I need to do, yeah. You can use customer segment and put to text like this, right? Yeah. So Mr. Aaron Bergman is a lost customer for us. Aaron Hawking, Aaron Smelling is a potential loyalist. And Adam Hart are loyal. These are at risk. They come recently, but they don't spend much. Yeah, we have these champions here. Arian Irving, right? Okay. Now, with this, for individual uh, people here may not give us something, right? First, we need to explore the segments of customer that we have just already done using the RFM. So for the sake of this, I will again use Tableau to help us to visualize or explore these segments that we have. So let's first count the number of customers in each segment. Right, so just new worksheet, and then I call this worksheet FM customer segment. Okay, and then I put customer segment to rows, and then I put what's that? Count distinct customer name. Yeah, count distinct customer name. Put customer name to column, and then change this to measure count distinct here. Right? Because customer name is dimension, of course. When we put it in columns, it will be the each customer, right? But we don't want that. We want just to count, but count distinct. Okay, just count distinct. Okay. And then just entire view. I want to make this bar to be different color, so I put customer segment to color. Okay. So this is what I got. Okay, so you get this, type 7. Oh, again, I want label, right? So I put count this thing to label. Okay. Anyone? No one? So to be better, visualizing this, we should sort, right, by what you can see the most VIP and the least VIP to be sorted, right? We can do manually sort, like using our drag and drop, like put loss up, right? But if we visualize this again, we need to do this many times, right? So again, we will use the default properties in Tableau to help us define the sorting so that we can use this sort later on in the many visualization that will come. So you can go to customer segment and then default properties, and then here the sort that you can define. Sort. Okay, once you get sort, you choose manual, right? And then you can loss should be up, at risk, then champion should be down, potential loyalist. Okay, should be like this, right? Loss, at risk, potential loyalist, loyal customers, and then the best one is champions. I use sort by manual. Okay, once you get this, then you can click the sort, and then it will have the option that you can sort by this manually that you already defined. Okay, and then what you do is here, you can see that we have the sort, like the small icon here. Click, I think click 3 times. You get the sort by the defined order that we just did with the default properties. So loss, 100 people, at risk, 200 people, potential loyalists, right? And champions, we got the 35. So these 35 people, we can give them VIP access, right? New products, maybe pre-order, like of the new products. And for these two, maybe we can give them some discounts. For those laws, mean we don't need to do anything with them. Just let them go. All right. Now let's explore more. So if you want to visualize the details of each segment, right, like this, we want the bar chart to provide us with some insights to each customer group, whether what are the behavior of potential loyalists, how much they spend, how recent they come, or how frequent they buy with us. Then you use this type of to see the average, right? The average of each of the segments here. Okay, so goes to new sheet, and then RFM, let's call segment details. Okay, and then I put row, customer segment to row. Okay, and then the score of the raw matrix, right? I want to look at the details, not the normalized score. I want to look at the details. So I use this start with RFM, right? R, F, and NM, right? However, I don't want sum. What I want is the average, right? The average of this type of this segment of customer. I don't want to sum all of them. So I change from sum to average. Okay, just entire view. All right. And then what do I need to do? I change the color to be gradient according to the value, right? So you can see we have 3 layers. For M, I use average FM to be color. For F, again, I use average F. For R, I use average R, right? Okay. And then I can sort by this using, okay, this is the sorting I want. So customer segment for row, average IFMR, average IFMF, and average IFMM. Then put the color to be gradient over each of these metrics. Now we want to make this color better, right? Because for F and M, I think these are okay already because we get the most intense color to be the most frequent and the most amount spent, monetary spent. So this should be good, but for recency, it should be reverse, right? So I will use different color. Let's see, I will use for R, I will change this to probably orange gold, right? Orange gold. And because the highest number is not good, it will be really late. Okay. Orange gold. And then I will do further. I will not called swap, reverse. It's called reverse because the highest not good, right? So I will not let them go to the same direction as the IFMF and IFMR. So I want different direction, right? So what I can do is I go to the average axis, right click, and then edit axis. And then I will choose the reversed one here. Reverse axis. Okay, when I choose the reverse, yeah, it looks like this, right? So you can see that if you are champions, you would spend on average about how much? I need to add label, right? So I put label on each of these. Average label, average F label, and also average M label. Okay. I can also set default properties of these labels, right? Let's say I want to set the RFM I set default properties of the number format. Let's say to be just full number and do not need the digit values, right? I need number custom maybe. Okay. Like this, right? No need to have like 73.5. Okay. Same as frequency. I want to be integer. So number format, I can set to number custom without, yeah, like just for the 5 days, 7 days is enough. And for the monetary value, I need maybe to choose currency format. Currency custom, do not need to have decimal places, just display using dollar sign. How about? Okay, looks good. So you can see that for champions, they come very recently in average from about 12 days ago, right? made around 11 purchases so far, and the average spend is about 5,600 something. Okay, so if you get this,เป็น customer segment ค่ะว่ามีอะไรบ้าง customer segment มีแค่นี้ เมื่อกี้เรามีซอสด้วยเราซอส customer segment using default properties sort นะคะแล้วเราก็เข้าไปเลือก manual sort ให้ซอสตามนี้ด้วยนะคะพอซอสตามนี้เวลาเรากดซอสตัวนี้มันจะมีออปชันหนึ่งที่มันซอสตามไอ้ manual sort เมื่อกี้นี้ให้โอเคทุกคนได้ไหมถ้าได้กดแป๊บอ่ะ Okay, then save this and today demo workshop should be done. Right? So let's spend some time exploring the application of RFM analysis a little bit, right? Calculating that from trouble is just technical things, right? Uh, the most valuable things that this create is about business, right? Why do we need all this math, right, to drive the actions? First, we can have like personalized marketing. In the modern business, we don't do one size fit all anymore, right? Email will goes, everyone will be probably different. So with IFM, allow us to tailor all these conversations with particular customer to be different. For instance, we should absolutely maybe target the champions with exclusive offers or exclusive access to the new products, right? Champions don't need heavy 50% off discounts. They already love your brand. So instead of offer them the discount, you get new product offer for them or invite them to the event, maybe with celebrities or influencers, right? Contrastly, we can do more strategic with some at-risk customer, right? They probably used to spend with us a little more, but we haven't seen them maybe in months. So maybe aggressive discount will help win them back. Next is customer retention. Retention means try to retain loyal customer as much as possible, right? This is, you already know, this is maybe some idiom or maxim that says that it costs more to acquire brand new customer than it does to keep the existing one ก็คือคุณก็คงเคยเห็นคนที่เขาพูดกันว่าการใช้เงินไปเพื่อหาตลาดใหม่หรือว่าหาลูกค้าใหม่เนี่ยมันต้องใช้เงินเยอะกว่าการที่จะรักษาลูกค้าเก่านะคะนั่นก็หมายความว่าบริษัทอย่างเช่นพวกรีเทลหรือว่าเทลโคเนี่ยเขาจะพยายามจะทำสิ่งที่เรียกว่าเป็น churn prediction นั่นเองนะคะก็คือเป็นเรื่องเดียวกันเนาะกับพวก customer retention เพราะฉะนั้น RFM allow us to focus on retaining loyal customer, right, by recognizing that they have some behavioral patterns and we want to ensure that maybe customer service team will prioritize them to prioritize their support tickets or maybe prioritize their requests นะคะ Third is the cross-selling, upselling. So once we identify who's the most engaged or the high spending segments, we can confidently promote the products relevant to them to possibly more high value product, right? For example, if your data shows that this segment is has a high frequency and high molecular score who buy maybe premium coffee machines, then they are the perfect person that we can also sell them maybe the coffee beans or the accessory about coffees, anything about coffees they would love to buy from you, right? And finally, probably more interesting for us or for uh, data analyst is to do the churn prediction. So IFM map things that are quite descriptive, right? It tells us what already happened, but they don't tells us what will happen next. Remember about the 4 layers of data analytics, right? So IFM are just descriptive and diagnostic, but maybe we want to be in the realm of predictive analytics. So we can directly use recency or frequency as strong predictors for machine learning churn models by feeding these numbers 1, 2, 3, 4, 5 to be one dimension in your or one feature in your algorithm, and then you can use this features to be the predictor of your churn model, right? So just like when we see algorithm, right? When we talk about this uh, different algorithm, maybe like random forest, logistic regression to predict whether this customer will leave us, will churn or not churn, right? You can add the recency, frequency, monetary score, right, into dimensions so that this will help us predict better because this IFM already reflect the behavior of the past behaviors of those customer patterns ค่ะ Okay, that's today. That's wrap up today's lecture, right? We talk about RFM analysis, which is a highly effective and behavior-based methodology for customer segmentation, right? By using tools like using Tableau, we can easily calculate, visualize, and then interpret these segments very easily and effectively. ค่ะ Try to drive some decision or action from the segments that we get from calculating these IFM scores. And implementing this will, of course, help us to identify what's needed for each of the business that we are dealing with, right? Try to maybe personalize people using some marketing strategy to improve profit and also to improve retention นะคะ Okay, that's it for today. This is the reference. Okay. Now, I think model จะพูดเกี่ยวกับnext step เนาะ so we are done with our lecture นะคะ next step is term project นะคะเรานัดกันวันที่28เมษายนนะคะก็คือ21จะไม่มีคลาสเนาะจะงดไปก็ให้เวลาเราไปทำนะคะแล้วก็อย่างที่ครูเขียนเม้นต์ไปอ่ะครูตั้งใจเม้นต์เลยนะแต่ละกลุ่มนะคะลองปรับปรุงตามนั้นนะคะแล้วก็คุณก็จะได้คะแนนดีขึ้นนะคะ28 April เนาะก็เวลาเรียนเรานี่แหละนะคะเราจะมีการ Present Final Project นะคะซึ่งการ Present Final Project ของวันที่28เนี่ยจะ Present คู่กับ CS อ่าจะไปเรียนคู่กับฉะนั้นต้องเตรียมเวลาไว้เลยนะน่าจะแบบถึง5-6 โมงเย็นอ่ะเพราะว่าสองเซกชันน่าจะประมาณ30กลุ่มได้นะคะแต่ว่าจะให้เวลากลุ่มเนาะแต่ละกลุ่มเนี่ยอันนี้ครูใส่ไว้ในหน้าที่ชื่อว่า Final Project Instruction and Rubric นะคะก็คือว่าให้พรีเซนต์7 นาที เหมือนกับวิดีโอที่ไม่ได้หมายความว่าเหมือนกับคือจำนวนนาทีเหมือนกับวิดีโอนะคะ7 นาทีจะไทยอังกฤษก็ได้แล้วก็เราจะมี question and answer 3 นาทีนะคะแต่ก่อนหน้านั้นคุณต้องส่งสไลด์เด็กกับ Project Canvas ก่อนนะคะซึ่งทุกอันจะต้องเรียบร้อยเนาะเติมมาเรียบร้อยแล้ว Project Canvas เติมเรียบร้อยแล้วสไลด์เด็กเติมเรียบร้อยแล้วแต่ว่าคุณไม่จำเป็นต้องเล่า Project Canvas อีกรอบนึงนะครูจะดูได้อยู่แล้วเนาะเพราะว่าไม่งั้นมันจะเสียเวลามากนะคะไปเน้นสิ่งที่เรียกว่าเป็นพวกหลักๆนะคะก็คือคุณก็มาดูว่าครูให้คะแนนจากอะไรบ้างเนาะแล้วก็อีกอันหนึ่งที่ต้องทำคือ GitHub นะคะใส่ลิงก์ไว้ก็คือคุณสร้างเอาไว้ให้มันมีลิงก์แต่ว่ายังไม่ต้องสมบูรณ์เพราะว่าครูยังไม่ตรวจนะคะแต่ก็ให้เวลาจนถึงวันสอบไฟนอลซึ่งแน่นอนเราจะสอบไฟนอลกันวันที่11พฤษภาตอนช่วงบ่ายเนาะบ่ายโมงนะคะก็คืออันนี้พูดนิดหนึ่งก็คือ11พฤษภาบ่ายโมงถึงบ่าย3นะคะที่ห้อง1815อันนี้คือสอบไฟนอลนะคะกลับมาพูดเรื่องโปรเจกต์นะคะก็ให้เวลาส่ง GitHub ไปอัปเดตได้จนถึงเที่ยงคืนวันที่11นะคะ อ่าวันที่พรีเซนต์นะคะจะเป็นอย่างนี้เนื่องจากเรามี13กลุ่มเนาะแต่ว่าเอ่อฝั่ง CS เขาจะมีประมาณ16กลุ่มนะคะดังนั้นเอ่อเดี๋ยวเราจะมีคะแนนคำถามคำตอบด้วยนะคะดูอย่างอื่นก่อนค่ะเซกชันแรกจะเป็นเรื่องนะการให้คะแนน statistic เนาะก็จะมีพวก background pain point เนี่ยให้7คะแนนเนาะอะไรจะได้7ต้องดูว่าจะอะไรจะได้7บ้างนะคะอะไร ลองลงมาเนาะแล้วก็สมาร์ททีฟสมาร์ทไหมบางคนไม่สมาร์ทใช่ไหมครูเม้นไปแล้วเนาะอ่าแล้วก็อย่าลืมความสอดคล้องระหว่างในโปรเจกต์แคนวาสกับที่พรีเซนต์ด้วยนะคะก็อาจจะเป็นเนี่ยนี่ครูก็แนะนำอันนี้เป็นยกตัวอย่างนะไม่ได้หมายความว่าจะต้องอย่างนี้นะ fault rate อะไรพวกนี้นี่คือยกตัวอย่างของแต่ละกลุ่มครูเห็นแล้วจะอาจจะมี objective ไม่เหมือนกันนะคะแต่ให้มันสมาร์ทแค่นี้ก็โอเคนะคะตามที่เม้นไปนั่นแหละนะคะ section 2อีก25 คะแนนก็จะเป็นพวกเรื่องของ 5W1H ใช้ hypothesis ตั้ง hypothesis อะไรพวกนี้เนาะอ่าแล้วก็มี GitHub 15 คะแนนเพราะฉะนั้นอ่าตรงนี้อาจจะไม่ได้เกี่ยวกับตัว live presentation นะคะอันนี้จะเป็นการให้คะแนนทีหลังเนาะก็คือคุณไปเขียนให้เรียบร้อยนะคะแล้วก็อัปโหลดพวกข้อมูลแล้วก็โค้ดต่างๆที่อยู่นะคะให้เข้าไปใน GitHub นะคะอ่า section 3จะเป็น data ก็จะมีการให้คะแนนของ quality ของ data นะคะก็ประมาณนี้เนาะ section 3ก็อีก20 คะแนนก็จะเป็น EDA กับ visualization นะคะก็คือคราวที่แล้วให้ไปแล้วใช่ไหมแต่ก็มีบางกลุ่มให้ปรับปรุงใช่ไหมถ้าคุณปรับปรุงมาเรียบร้อยแล้วคุณก็จะได้คะแนนเยอะขึ้นนะคะ section 4จะเป็น finding ละดูว่า findings interpret เป็นยังไงบ้างนะคะ recommendation work ไหมนะคะแล้วก็ section 5จะเป็นเรื่อง presentation นะคะกับ defense เนาะก็คือ10 คะแนน ก็คือ7 มินิทพรีเซนต์3 มินิทตอบคำถามดังนั้นคนที่เป็นพรีเซนต์กลุ่มพรีเซนต์จะต้องตอบคำถามแล้วก็อยู่ในคะแนน10 คะแนนนี้ด้วยส่วนกลุ่มที่เป็นคนถามจะมีคะแนนคนถามด้วยก็คือตรงนี้5 คะแนนคนถามก็ต้องถามด้วยคำถามที่ชาร์ปใช่ไหมถ้าไปถามแบบอะไรคืออันนี้อะไรอย่างเงี้ยก็จะได้คะแนนน้อยลงนะคะหรือถ้าไม่ยอมถามหรือว่ามีแค่ อิดออดออดอะไรเงี้ยก็จะได้1 คะแนนนะคะเพราะฉะนั้นคนถามแต่ถามอย่างนี้ก็คือเนื่องจาก CS มี10CS มี16กลุ่ม DE มี13กลุ่มของเรา DE เนี่ยไม่มีปัญหามากก็คือ DE กลุ่มหนึ่งนะคะก็จะถาม CS กลุ่มหนึ่งอะไรอย่างเงี้ยเนาะประมาณเนี้ยนะคะเดี๋ยวเราค่อยพูดเอ่อโปรโตคอลกันวันที่พรีเซนต์อีกทีนะคะแล้วก็ตัวอย่างงานเขียนบน GitHub นะคะครูมีตัวอย่าง4 กลุ่มของรุ่นพี่ปอโทเนาะลองเข้าไปดูว่า เขาเขียนยังไงเนาะอันนี้คือกลุ่มที่เขียนแล้วดีเขียนแล้วได้คะแนนดีเนาะนี่เขาเขียนมานะมี objective มีบทนำก็คือจริงๆแล้วก็คือมาจากไอ้ตัว Canvas นั่นแหละนะคะ Data เด็กนู่นนี่นั่นนะคะอ่ะอธิบายว่าเจออะไรบ้างนะคะอะไรแบบนี้เนาะนะก็คือตอนไลฟ์เนี่ยมัน7 มินิทมันอาจจะอธิบายไม่หมดGitHub คุณสามารถขยายความได้เนาะอ่ะหรืออันนี้อ่ะ ก็ประมาณนี้เห็นไหมคุย question เป็นยังไงมี Data อะไรบ้างคลีนยังไงนู่นนี่นั่นวิเคราะห์แล้วได้อะไรเนาะก็แล้วเขาก็เนี่ยอันนี้กลุ่มนี้น่าจะส่งเห็นไหมมี Data มาให้เนาะคุณก็ submit Data submit Code อะไรเข้ามาได้นะคะหลักๆคือดูงานเขียนเนาะ แต่มันก็จะเป็นพอร์ตของคุณอะเนาะเวลาคุณไปสมัครงานคุณก็เอาอันนี้เป็นพอร์ตเป็นส่วนหนึ่งของพอร์ตได้อย่างเช่นกลุ่มเนี้ยเขาก็ส่งทั้งโค้ดแล้วก็ส่งทั้งทับโลไฟล์ส่งทั้ง Data มาให้ด้วยนะคะ ก็ไปดูตัวอย่างพี่ก็ได้เนาะอันนี้ก็กลุ่มที่เขียนดีละนะคะโอเคประมาณนี้มีคำถามเกี่ยวกับตัวโปรเจกต์ไหมเอ่ยแล้วก็ตัว submit project ก็จะอยู่ในลิงก์นี้แล้วเนาะก็คืออันนี้อ่ะ final project submission นะครูเซตวันไว้28 April เนาะแต่ว่าเอ่ออย่างที่บอก GitHub เนี่ยคุณใส่ลิงก์ไว้ให้ก่อนแล้วก็คุณค่อยไปอัปเดตได้จนถึงวันที่11นะคะอ่ะมีคำถามไหมเอ่ย ถ้ามีคำถามแล้วก็GitHub ต้องสร้างทุกคนไหมครับไม่ก็สร้างคนเดียวแต่ว่าลิงก์เวลาส่งก็ลิงก์เดียวกันนะใช่ไหมก็กลุ่มหนึ่งสร้างอันเดียวพอนะคะโอเคแล้วก็ Final Exam อันนี้ Final Exam เนอะอ่ามันจะไม่เหมือนปีที่แล้วละก็คือ Final Exam ปีนี้ก็จะเป็นแบบ ใช้ SEB สอบนะคะเพราะฉะนั้นคุณไม่ได้ให้คุณทำทับโลเนาะแต่ว่าอาจจะมีแคปเจอร์หน้าจอให้แล้วก็ถามว่าอันเนี้ยคือทำอะไรนะคะหรือว่าให้กราฟแล้วก็ interpret นะคะเลือกเป็น choice หรือว่าเขียนอยู่ในตัวเอ่อ SEB นะคะแล้วก็ส่วนใหญ่ก็จะเป็นทฤษฎีคล้ายๆกับควิสนี่แหละนะคะถ้าเป็นสอบเนาะเพราะฉะนั้นควิสครั้งนี้ก็ยังมีอยู่เนาะ นะเทิร์นโอเคควิส12ควิสให้เวลาทำถึงคืนพรุ่งนี้นะคะเหมือนเดิมเนาะก็คือควิส12เนี่ยก็ถามวิธีการคำนวณ RFM นี่แหละนะคะให้เวลาทำถึงพุธนะคะคือคืนพรุ่งนี้เที่ยงคืนนะคะก่อนเที่ยงคืนนิดหนึ่งนะคะ โอเคเนาะประมาณนี้ก็ขอให้โชคดีนะในวันสอบทุกคนนะโชค A ใช่ไหมแล้วก็เอ่อขอให้เอ่อได้คะแนน Presentation แล้วก็คะแนนโปรเจกต์ดีๆด้วยนะคะก็แล้วเจอกันโอเคเล่นน้ำก็ระวังความปลอดภัยด้วยเนาะอืม